All right, number 6, we're going to determine whether the intermediate value theorem guarantees that the function has a 0 in the interval. So what the intermediate value theorem is we're going to plug in the two x values and we're going to get a y value. Okay, and so let's just say we're on 1 and 2. Here's 2 points. So the graph could do a couple things. The graph could go up and stay up. It could be coming and go down between, and it could come back up, or it could simply be below on one point and above on the other point. The intermediate value theorem is trying to see if one value is negative and the other value is positive. So what that says, if the graph changes signs, the y value from negative to positive or vice versa, then somewhere in between those two numbers the graph had to cross 0. There's no way to go from negative to positive unless you go cross 0. So we don't see the graph, we don't know, but we're going to test and use the intermediate value theorem, and if the signs are opposite, we know that there's a 0 between. If the signs are the same, we don't know. So the graph could go down and come back up, and in this case they could both give you a positive value. The intermediate value theorem would be inconclusive if that was the case. So I'm going to again do this with synthetic division. So we have z of x. Okay, they just changed the first letter all the time. It doesn't mean anything. It's just a y value. 2x to the third minus 11x squared plus 7x and then plus 4. And I'm going to do synthetic division with the numbers 1 and 2, and we'll see. So I'm going to do 1 first. 1's going to go in my box. 2, negative 11, 7, and 4. Bring down the first term. 2 times 1 is 2. We'll subtract. We'll get a negative 9. 1 times negative 9, negative 9. Subtract, we'll get a negative 2. 1 times negative 2, negative 2. We'll get a positive 2. So that one comes out positive 2. Do the same thing again with the number 2. 2, negative 11, 7, and 4. Bring the 2 straight down. 2 times 2 is 4. Subtract negative 7. 2 times negative 7, negative 14. Subtract, we'll get a negative 7. 2 times negative 7, negative 14. And combine, and we get a negative 10. Okay, so we can see we go from a positive to a negative. So that guarantees us that somewhere between the numbers 1 and 2, this graph had to cross the line 0. So it says since z of 1 and z of 2 have opposite signs, intermediate value theorem guarantees the existence of at least one 0 in this interval. All I need to put in the values. We got 2 and negative 10. All right. And then it says, therefore the function has a 0 on the interval. The graph must cross the x-axis somewhere between 1 and 2. So this is just further explaining intermediate value theorem. We can now do the same thing with 2 and 3. So since we've already calculated 2 is there, we're just going to now do the number 3. So I'm going to extend and do 3. I'm sorry, I didn't realize that's kind of off. My numbers over there. So I'm going to do 3. And the same numbers 2, negative 11, 7, and 4. Bring the first one straight down. 3 times 2 is 6. Subtract negative 5. 3 and negative 5 gives me negative 15. Subtract, we get negative 8. 3 and negative 8 will give me a negative 24. Gives me a negative 20. All right, so here when we compare these two, both signs are the same, both negative. So the graph could stay down at the bottom. It could go and cross, but we don't know. So this one comes out to be a negative 20. And since it says have opposite signs, do not have opposite signs. They have the same sign. Intermediate value theorem does not guarantee the existence of at least one zero on the interval 2 to 3. If we do a z of 4, okay, I can do the same thing. So I'm looking between 3 and 4. I'll just kind of come over here and do 4, 2, negative 11, 7, 4. Bring the 2 straight down. 4 times 2, 8. Subtract negative 3. 4 times negative 3, negative 12. Subtract negative 5. 4 and 5, negative 20. And we get negative 16. Okay. So negative 16 when we plug in 4. Again, the signs are the same, so they do not have opposite signs. Intermediate value theorem does not guarantee the existence of a zero on that interval. Now, it doesn't say that there's not, but just they can't tell. All right, so we do the same thing with 5. Two, negative 11, 7, and 4. 5 times 2 is 10. Negative 1, 5 and negative 1 will give us negative 5. This will give us a positive 2. 5 and 2 is 10. And this gives us 14. So 14 has the opposite sign of negative 16. So they do have opposite signs. That does guarantee that we have a zero in that interval. And it says, therefore, the function has a zero on the interval 4, 5. The graph must cross the x-axis somewhere between x equals 4 and x equals 5. So that's all the intermediate value theorem does, is check to see if the signs are opposite signs, and you can tell if there's a zero or not.